Hello everyone. Today we will be solving the lead code problem, longest increasing path in matrix. Okay, so let's read the question first. Given an m cross n integers matrix, return the length of longest increasing path in matrix. For each cell, you can either move in four direction, left, right, up, or down. You may not move diagonally or move outside boundaries. That is, wrap around is not allowed. Okay, so in this matrix, the longest increasing path is it's strictly increasing, right? I mean, they are not starting from this one, they are starting from this one, and they are going till 9, and 9 is not going on the second 9, so it's a strictly increasing path. Okay, so we have to give the length of strictly increasing path, like in this matrix, the strictly increasing path length is 4, like 1, 2, 6, 9. Okay, so in this matrix, the strictly increasing path length is 4, also 4, like 3, 4, 5, 6. In this matrix, it's 1, as only one element is present. Okay, so let's take the first example here. Okay, 9, 9, 4, 6, 6, 8. Now, what can be the approach? I mean, what approach do you think we can apply for this problem for strictly increasing path length in matrix? Okay, so for this, we can use, we can do DFS from each vertex, each, uh, let's say, element of matrix. Okay, like from the first element, we can do DFS in the four directions with the conditions applied such that the next element of the DFS should be greater than the previous one. Like if we are starting our DFS from this element, it will move in four directions. Okay, like this. As outside matrix is not allowed, so it won't go here. So but it will go here too. As 2 is greater than 1, so it will jump to 2. Now from 2, 2 can also go in these four directions, right? To the previous one as well. But now we have put it the condition like the next element on which we will be going should be greater than the current element. So from 2 it will not go to the 1 because 1 is less than 2 and 6 is greater than 2, so it will go to 6. Okay. Now from 6 it can go to here, here, here and here in the four directions. But as per the conditions, conditions are like we cannot go outside matrix. Okay, the next element on which we will be doing DFS should be next element should be greater than current element. Okay, and okay, this is the condition. And what can be the other conditions? Like yeah, these are the two conditions which we strictly have to follow. But here is, I think, I mean, for DFS of each uh, element, we should think about the time complexity then. Like for this question, the time complexity is, let's see, what is the time complexity? It's 200, right? Yeah. So for each element, it goes to m into n, like 4 into 10 to the power 4. This is for each the visiting each element of the matrix, and for DFS as well it will take same 4 into 10 to the power 4. Okay, so it will nearly because 16 into 10 to the power 8, which is nearly 10 to the power 9, with this time complexity, which is greater than 10 to the power 6, so this time complexity will definitely give time limit exceeded. Okay, so what can we do? So here we can use DP, yeah, dynamic programming. Okay, so here we can do one thing, like in this example, 9 9 4 6 6 8 2 1 1. Okay, for this problem we can do in this way, like suppose we are on this element, okay, and we perform DFS for this vertex first. Let's see. Let's suppose then uh, where it will go. It will go to this element only as per the condition, right? And from this element, it will stop here. The DFS will stop here because it can't go outside the matrix, and there is no element to its right or down such that the next element is greater than that this 9. Okay, so it will stop here. So for DFS value, I mean the path, the increasing path length from this 6 is 2. Okay, so let's say, okay, so for this 6, it's 2. Now, for this 6, let's say, for this 6, it can go to the above one or the right one. And from this 2, it won't go further. So, for this as well, it's 2. From 8. For 8, the length is 1 because it can't go anywhere. For 2, now here comes the play role of dynamic programming. Now, when from 2, I can go to this 6, right? But when I visit this 6, I don't have to go anywhere further because I have already calculated the longest path from 6. Okay, that is 2. So the from 2 it is 1 plus the next 6. For 6 it's 2. I mean for this 2 the value is 3. If you're familiar with the dynamic programming, you might have got the idea, like we have already computed this result, so we will be reusing them again, right? So this problem is basically the combination of DFS plus DP, right? Let's code this problem. Okay, so first let's take the length, number of rows of matrix dot size, and the number of columns and matrix of 0 dot size, right? Now what we'll do, we'll yeah, so now we will make one function for the DFS, let's say. Okay, void DFS. Now here we will need the current vertex points from which we'll be starting the DFS, right? So it's int I, j, and m. Nm is for the number of rows and number of columns, so that we can prevent the DFS from going outside the matrix, right? Now the next thing is vertex itself. I mean, sorry, matrix itself. So next thing is, okay, let's call it V only. Now, okay, we'll apply the DP afterwards. Let's deal with this first only. Okay, so we'll make one function to prevent our DFS from going outside. Okay, so is let's name it is okay, and let's pass the vertex like int m. Okay, so if I is less than 0 or I is greater than or equals to n or j is less than 0 or j is greater than or equals to m, then just return false, and then otherwise return true. Okay. So if our vertex is going outside the matrix, that means our BFS is going outside the matrix, then we will receive the false as a response. Okay. So for this, let's apply this condition only first. So if is okay, I, j, n, m equals to false, then we'll just return from there. So no need to go further as DFS has already crossed the matrix. Okay. So the next condition was the next element should be uh, greater than the previous element. So we need to keep track of the previous element as well. Into previous. Okay. So now as the int current element equals to v of I j. Okay. So if current element is greater than no no the current element is less than or equals to the previous element, then we'll just return. This is the condition where I'll explain this condition. Let's say this is the condition like this. Suppose this is my current element where my DFS is right now, and this is the previous one. So according to the question, I should not go from here to here, right? So my current element was 4 and my previous element was 9. So my current, if my current element is less than or equal to previous one, then I should not proceed this DFS, right? So that's why I have this condition like okay. Now let's do the DFS. Okay, for up, let's say int up DFS like DFS I minus 1 for up j and m v previous. Okay, int down equals to DFS I plus 1 j and m previous. Okay, int right equals to DFS I comma j plus 1 comma n m previous. Okay, int right, sorry, int left equals to DFS I comma j minus 1 comma n m previous. Okay, so now okay, so while doing this DFS, we are going from first element to the next element, right? So we should keep count of that length, like 1 plus, right? Uh, I'll, I'll explain this. Okay, if I'm going from, let's draw that matrix again, 6, 6, 8, 2, 2, 1. Suppose I'm going from this to this element, right? So this counts in the length as one, right? This is one length. Then this is I'm going to the next DFS. From here it goes to here. Then this plus one. Then here it gives one, right? Okay. So according to this, it should be plus one. Now, I need to return the maximum. I mean the int longest path from this all the DFS like int down, right, and left, right? So I'll just return this longest path. Now let's call this DFS. Okay, as I need the longest path from this, I'll just keep track of all the DFS. I mean, which DFS is giving me the longest, what we can say, path. Yeah. And as we'll be returning this value, we should not give it as a void then. We should give it as a int DFS. Yeah, int DFS. Yeah, right. in DFS. And if it's say then zero, then zero, yeah, and yeah. So let's call this DFS for each element. As we haven't applied dynamic programming, I mean we haven't memoized this problem. So this should ideally give an TLE to us, time limit exceeded. Let's see. J, J plus plus. Okay. Now we'll keep track of the longest path in this. Answer equals to uh, int min, not int min, as we'll be using the length only. We'll be keeping track of length only, so we can keep it as a zero only, right? So answer and DFS of I comma j comma n comma m comma matrix comma. Let's give it for the -1 for the previous as a starting. Okay, and we'll be returning answer only. This should give time limit exit error. Okay, what is the problem here? Call expected for more than. Okay, okay. We, we, okay. Okay, now, okay, yeah, it gave time limit exceeded for the sample test case only. Now, what we'll do, we'll just store the results in the in one DP vector. I mean, calculated results in the DP vector, and we will reuse them. That's the concept of dynamic programming, right? Let's make one vector of same size as the matrix. M comma. Let's initialize it with -1. Let's pass it, right? DP, and let's take it here as a reference, or let's take this as a reference in this vector. Now, if we have already calculated its result for this DFS, then we'll just return those, and we will store all the calculated in, and if we don't have this calculated results here, then we'll just calculate them here and we'll just store them, right? Let's just store them, and for simplicity of the code, let's return it from here. We can do in that in the previous way as well, but just for the simplicity of your understanding, we'll do it in this way. Okay, now I guess all set now. Okay, let's see for this code. Okay, what is the problem? Okay, for this as well, we do have to pass the reference as DP, 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 yeah, DP. Okay, this should work. Okay, time limit exceeded. What went wrong? Okay, return zero. If we don't, if we have already calculated those results, then we will just return them, right? And for this, okay, okay, calculated. Okay, okay. I think I need to store these results as well. If any vertex is not giving the current, if it's not providing any, yeah. What went wrong? They're saying that lately overflow. Okay, we messed up somewhere. Let's see. Okay, okay. No, no, no need to stay, save it here actually, because this will be returned in this longest path and it will store it here automatically. So this is a base condition. So if current is less than the previous one, then what is the it starts from zero, so it should not give problem to this. Minus one. Now minus 1, j plus 1, j minus 1, n m. If I is less than 0, q or I is greater than or equals to j this is also true. So if it is outside the matrix, then also we return this condition, right? And for matrix previous and it should not give any problem. Let's see now. Answer equals to answer minus. Okay, okay, is okay. And then if TPR is not equals to minus one, it should work. Okay, let's try run our code here. 994668211. Okay, so if the current element is less than or equals to the previous one, then we should return zero. Yeah, so uh, suppose we are on 9, right? We are on 9. Then for 9, we'll be doing DFS to the right, which is 9 already, and the downside, which is 6. So the current element will be uh, yeah, with 6. When we go to the 9, its previous one is already 9, right? So it will return 0 here from here only. For this 6, we will go to the 9 from here itself and we will return 2 and current is less than or equals to previous one. Let's try run this code. 994668221. Okay, now we are here. We will be doing DFS to this, this, and this, and this. For this two, we will get 0, 0. And for this condition, we'll go to the this element and then we will realize that the current 9 and the previous one will be okay, we have passed previous as right or what? No, the previous should be the current element, right? For the next element, current will be the previous. Yeah, okay. Now it should definitely work, I guess. Yeah. So for the next element we'll be giving, I'll explain this to you. Yeah, it got accepted. For the okay. So now when you reach to the next element, this current will act as a previous to you, right? Right. So when you do DFS from this to this becomes your current and this current becomes your previous. That's why this condition is here, right? that your current will become the previous for the next DFS call. Yeah. Thank you, everyone.